So now I'm going to go over the EDS detector, the Oxford EDS. This is how we're going to tell what elements we're actually looking at. So before we can just get an image of it, now we can actually see what materials we're looking at. So to do that, we're going to use a software called Aztec. So we're going to come over here and we're going to open up. We'll double click on this. So this detector is run through this box down here. So this Oxford box X1, that controls this detector, and then that's hooked up to our computer as well.
Did you just turn it on? Or?
It's that one we leave on. Yes.
At the end of the day, when we turn off the computer and the system, that's always on still?
Yes, leave that on still. Yes, leave the Oxford box on. Yeah. So yeah, the question was, what do we do if there's a power outage? So if there's a planned outage, right, shut everything down. If you know that's going to happen. If there's an unplanned outage, what's nice about this system, that's why we use compressed air for the valving. So there's still air pressure. If we lose power, it'll shut itself down safely. So there are safety features built in. But yeah, if there's going to be the doing work in the building, yeah, always shut. Turn the key off, shut the computer off as well. So when I opened Aztec, the window opened up on this side. Just drag it over to this monitor. So we still need to. This software does talk to our software. So if you notice here, it's actually telling us our working distance is 6.55. So it's reading that. It's telling us our optimal's at 10. You can use it, you'll get x-rays, but it's not optimal. So we're going to come back to our Z tilt and window, and we're just going to, we can grab this guy, or you see down here, it actually tells us analysis position. Is our counts. So our input count rate, to increase that, we're going to increase our spot size, okay? Because now we're going to have a bigger spot, more signals, more x-rays. X-rays don't care if we're in focus, how good the image is, it doesn't matter. we're just collecting X-rays, okay? So we turn this up to 70. Wow, now look how many counts I'm getting, okay? I went from 10,000, now I'm at 40,000.
So what was the spot size before?
50. So just going from 50 to 70, we jumped up exponentially. So you'll also notice if we increase our signal, we also increase what's called our dead time. So if this dead time gets in the red area, that's too high. Then we're just going to back down. Dead time,
Okay.
we're going to back down our signal. We've got too much.
So you change that by the spot size?
Yeah, correct. Spot size or aperture size. We'll do both.
What is the dead time? What does that mean?
Dead time is the time when you're not analyzing. So actually you want that to be in the green as well. So if you're around 50 for dead time, and then we're getting, so the more counts, the quicker it can do its analysis. Okay, so
all of these counts should be green.
yeah, as long as you're in the green, you're good. Yeah, we're getting, this is plenty of signal. So the way this software works is you can start a project, give it a name, and you can describe it. You don't have to put all that stuff in. So you have options here of analyzer, which is just going to give you a spectrum of your different elements. So basically whatever we have, we're seeing in the live scan, we're going to capture an image over here. So this software is going to take control of the scan. So we're going to go to scanned image and hit start. And what that's going to do is it's going to take the scan, the image, and put it over here. Okay? So whatever we see on the SCM, we're going to see now. So once we capture this image, now we can come to acquire spectrum. And over here we can do a point, we can draw a box, a circle, or freehand on any area that we want, because maybe we don't want to do the whole area. We can just pick an area. So I'll draw a box. And as soon as I click that, now it's going to start collecting the spectrum. So the beam is only scanning. And actually it did it that quick. It's done already. And it shows us carbon, gold, right? So this is gold. We know that. And then some trace elements of oxygen, tantalum. So I can draw a box on that really bright area. Now we can come to confirm elements. And it shows us here on the periodic table which elements there are.
You can add an eliminator.
Right. You can add, so it auto ID'd these ones for us. So if you know there's not an element in there, sometimes it shows up, you can remove it. And then now this gives us our quantitative results. So they're telling us the percentage of each element in that area. So 93% carbon, 6% gold. So now if I want to go to a new area, you know, we can move to a new area.
Does the result save?
Yes, so it saves it in that project that we created, okay?
So in terms of resolution, whatever we could get over there is what we will get for the X-rays as well.
So whatever we get here for imaging is going to be the image here, but like I said, X-rays don't care about a pretty image. They just, but
Like,
yes.
for example, if I want to get the composition of a single island, gold island over there, would I be able to do that?
So just one of the small, you'd have to zoom in on that. Yes, yeah, and then just do the point and just put one point there. Yes. So we're going to come back to the scanned image. And this one's still here. So you can see here, it makes a little flow chart of everything we've done so far. So under this image, we've done 2 different spectrums. So I'm going to hit new site. And now I'm going to capture this image. So you can see, you know, this is out of focus. That's okay. This is our stub, which I'm pretty sure is aluminum, but we're going to check that. And then this is the material that we glued our sample down to the aluminum stub. So now we're going to go to acquire spectrum. So we'll draw a box there. Man, I'm good. It's that fast. It's that fast because we have so much signal. And you can actually see, look at that. It made a box there because it only scanned that area. So
that's the electron beam damage?
That's some contamination from the beam, yes. Yep. So it looks like it's just carbon paste. And then this one, yeah, we should get some gold and carbon. So now if we click on our data tree, you can see first site, second site.
Along the image.
Along with the image, yes. So then when you save this, I'll put it to a report, it'll have the image and then the different spectrum below. So if we click on report results, it'll save it as a Word document. It opens up in Word. So it only showed the second one. So I'm just showing you guys the basics of this. There's different ways. You have to set up different templates, and then you can tell it to put out all the images with that spectrum. So that is point and ID. So if we just did analyzer, it's only looking at what the beam is scanning right now. So it's doing the whole sample.
Okay.
So if I hit start, it's doing everything, right? I'm getting aluminum, carbon, because we're doing the entire sample. Yeah, the whole screen.
That's dropping pump that we picked up.
So that noise we're hearing is the air compressor. So like I said, you might hear that kick in once or twice a day. So line scan, same thing. We can create a new site, start. And remember, you can use this in variable pressure mode as well. And if you code a sample, say you carbon coded, gold, platinum, you can do EDS, and you can tell it what you coated it with and how thick the coating is, and it'll take that into account and subtract that out of your analysis if you want. So then now we could draw a line, hit start, and it's only collecting x-rays across that line. And then you can shows, you know, over here is aluminum, you know, different.
Yep.
So the other thing I didn't mention, when we're doing EDS, you want to be at least at 15 kV or higher, because we're not going to be able to see all the elements on the periodic table. You know, if you only go up to 10 kV, you're only going to be able to see certain elements. You're not going to see the whole thing. You're not going to be able to excite those x-rays. So that's why you need to be at least 15, usually 20 is what people use for when they're doing the EDS analysis. And then I'll show you the map. So we'll do a new site. So you actually see our dead time is now in the red. So it's kind of depending where the beam's scanning at, that's why. So we can turn this down.
So you turn the spot size down?
I turn the spot size down, yeah. Oh, you know what? You know why we don't have a live image here? Because this still has scan control.
Is the dead time something that'll damage the machine, or just don't get a good scan?
Right, it's not going to, no. He asks, is the dead time going to damage it? No, it'll shut itself off if you put too much signal. So we could actually go to 100 dead time. It's not going to hurt it. It just floods the detector, so it's not working. So that's a good thing that just happened. So the EDS software still had control of the beam, and that's why I did not have a live image over here. So you always want to make sure you stop it, because sometimes we do that. We think something's wrong because I don't have an image over here, but actually the box still has control.
And how did you stop that?
I just came here and hit stop.
Ah.
So the live scan just keeps going.
Right.
And you don't, you actually have to stop it. Where the point ID and the analyzer will just scan till it gets the results it needs, and then stops. So. So this is the mapping. So it's going to keep scanning the entire image, and then the longer you let it, the more accurate it's going to be. So you can see it's going to actually give colors to the different elements here. And those color, you can change the color. It's not like, you know, it has to be. So now it's showing, okay, this is aluminum, right? But look, I got a little bit in here. The concentration of carbon. You know, my gold. I guess gold should be yellow, right? So the longer you let this go, the more accurate it'll be, fill in, and then it has the colors here. So yeah, that's kind of, yeah. And then it shows our percentages here, so. So, you know, mapping is something you would want to do. And the mapping also is just going to keep running until we hit stop. Now we'll hit stop. The report. And then it shows that map in here. So I didn't show you guys the shutdown procedure yet. So when you're done for the day, you can, you know, close out the EDS software. It's going to ask you, do you want to save the project? We're going to say no, because we were just doing that for training. We're done with the beam here, so we're going to turn off the beam, hit stop. So it's probably a good idea to take your specimen out, you know, because you don't know who's going to come in here next. So we're going to hit specimen exchange. And because we're just removing, we're not putting a new one in, we're going to hit remove specimen.
So what's the difference?
So remove specimen, so the question is, what's the difference between exchange and remove? Remove, it's just going to vent it. We take our sample out, we close it, and then we can pump it back down. Exchange, we'll go through that whole procedure of sample size and height, and so it's assuming we're going to keep using the system, and we're just going to put a different sample in. Yeah. Yeah.
So when you exchange, we want to change the sample.
Yeah, so if we're going to keep using it, but we're just going to load a new sample, we'll just do exchange. Even though we're taking the old one out, it assumes we're putting a new one right back in. But since we're just pulling it out, and we're going to pump it back down and then exit out of the software, we're going to do a remove specimen. So you can see on the front, it's blinking orange. Once that's solid, that means it's at air. So that beep means it's at air. So it tells us we can open the door. We're just going to remove the sample. Slides out on the dovetail. We're going to close the door. And now we see the evac is active again. It should start pumping. So at this point, If you're done, then you can just close out the software, hit X out, just like any other software, close out. Before you shut down the system, let it pump completely down. Let this light go solid so it's totally pumped down, and then you can turn the key off. So exit out of the software. You don't have to shut the computer down if you don't want to yet, but exit out of the software and then turn the key off. Otherwise, you get an error message if the software was still open when you powered down the SEM. And then the startup is just the reverse, right? We went over that earlier. Turn the key on, start the software, and load your sample. So that pretty much covers the basic training, basic operation. I can go over the filament replacement